Hi, this is a Technology RideCast. I'm Mark Farley, and our special guest this afternoon is Stephen Bates. How you doing, Stephen?
I'm doing very well, Mark. Thank you very much for having me. Super excited to be here.
Yeah, and I just saw your presentation here at Storage Developers Conference 2016. You were talking about persistent memories and application access to it.
Yep, it's a topic I'm super excited about. I think we had a great crowd at SNIA's Storage Developer Conference today.
Yeah.
And I'm really looking forward to talking to you a little more and explaining a little bit about persistent memory and what we think it means for the industry and how we're going to turn on applications to take advantage of these pretty exciting new memory technologies.
So what are the characteristics of persistent memory that make it such a game changer?
Yeah, that's a good question, Mark. So to differentiate persistent memory from maybe the NAND that we've used in the SSDs, I tend to use three basic attributes. The first of those is low latency. Persistent memory for me is really about getting faster access to the data, getting that data to the CPUs quicker so that it can process it. The second attribute is memory semantic. So NAND has this fundamental characteristic that you can't modify in place. I can't just do random writes to raw NAND. And that's meant we've had to put controllers in front of it. Those controllers run firmware, and that manages a layer of indirection we often call the flash translation layer. Persistent memory throws all that away. It's actually byte addressable, so we can talk to it in small chunks, and I can modify in place. And then the third attribute is what I call the storage characteristics. The most obvious one is something like persistence. Of course, persistent memory has to be non-volatile and maintain the data across power loss. But on top of that, there's other things like data integrity, encryption, and the ability to RAID the data so that it's safe if parts of the system fail. These are other important storage attributes. And something that satisfies to some level those three bins that I just mentioned, that to me is a persistent memory.
What's going on while all this hardware is being built, while these devices are being built in the software stack?
And we have what I call the PM jigsaw. This is like a jigsaw puzzle that has constituent pieces that are the building blocks that we all, as part of the industry, need to go work on. So the first piece of the jigsaw is what we just talked about, the bare memory itself. The second part is connecting applications to that through operating system support and library support. And there's an awful lot of work that's happening right now across all the operating systems to turn on this persistent memory. So if you go take a look, for example, at the Linux kernel, we have a lot of activity around the NVDIMM support section of the Linux kernel. That's really changed an awful lot in the last 18 months. Windows also has great support, Windows Server 2016, for these persistent memory technologies, and similarly for VMware and the other major operating systems. And then the next thing that has to happen, of course, is that application developers have to either think about two different choices. They have to decide, do I want to consume this persistent memory without rewriting my application and getting better performance, but maybe not the best performance? Or am I going to take the full leap and actually go and maybe rewrite parts of my compute stack in the application in order to take really full advantage of the persistent memory?
This is the most exciting stuff in the storage industry since the mid 90s, late 90s, when you started having storage networking coming out. It's got the same excitement about it. It's got the same speed.
Not only is it affecting the storage stack, but because we're going to treat it as memory in certain cases, it affects the compute stack as well. And we moved away from just increasing the clock speed of a processor core. That also required a large rethink about how we write operating systems, how we connect applications to take full advantage of it.
You know, when I had Jay Metz in the car a couple of weeks ago, he was wearing this really sporty fedora.
I've got to admit, Jay had a very snazzy hat. I tried to get the snazziest, dapperest hat I could, but you know what? I can't compete with Jay. He did a really good job there.
Thanks so much for coming along today.
Mark, thanks very much for having me. This has been great.